So what we're going to start off with today is we're going to take a look at this type of situation. Let's say we have across here, this is going to measure 50 millimeters. We're going to give this a depth of, let's go with 10 millimeters for now. We'll give this here 60 millimeters, 80 millimeters, and 200 millimeters. So what I want to find here, I want to find two things. I want to find the radius of the arc. This arc here, what's the radius of the circle that contains it, in other words? And then the total volume of the block. So let's start out with that arc. I'm going to start out with a circle over here, or we're going to pretend it looks like a circle at least. Yes. So we've got 50 millimeters across here. And this here was 10. So we'll extend this up here. We're going to find that measurement. I'm going to call that X for now. We know that, how do we find X? There we go. Perfect. We got to split that in half, yes. So 25 times 25 equals 10 times X. So X is 62.5, which means the diameter is 72.5 millimeters, which means our radius is 36.25 millimeters. Any questions so far? Well, let's continue with this picture then. Right here, I'm going to draw that in. That is 36.25. And that, of course, is 36.25. What's this distance here? It's 26.25. How'd I get that? Perfect. My radius, which is from here out to here, minus that 10 that's here. So we've got those dimensions. That's going to give me the area of that triangle, which I'll need in a minute. I also need to have this angle here so I can find the area of that sector. But what I'm going to do is I'm going to actually find just this angle. And then I'll double it because I know that's half of that whole angle. So that angle right there is from this triangle. This down here is 25. And this is 36.25. So according to this angle that I'm looking for, I have which two sides? Which two sides do I have? of the opposite and hypotenuse. And yes, that is a sine. So sine of theta, opposite over hypotenuse. This time I do not know the angle. That's what I'm looking for. Opposite side is 25. Hypotenuse is 36.25. So since I am looking for the angle, it's going to be an inverse trig function. So an inverse sine in this case. So my angle is the inverse sine, second sine, 25 divided by 36.25. Close my parentheses. 43.60. Now we're going to double that to get that whole angle. So times 2 is 87.21, it looks like. That's this angle here. So I'm going to find the angle of, or the area, I should say, of this whole sector here. To do that, I'm going to find the area of the whole circle. That's going to be pi times radius squared, 36.25 squared. So 4126.16 millimeters squared. Find the area of the sector. I then take that area of the circle times that angle, 87.21, 360. $999.56 millimeters squared. That is the area of that sector. And now I need to find the area of the triangle and subtract. I've already laid all the groundwork for the triangle. The base across here is 50. The height is the 26.25. We divide by 2 because it's a triangle. Yes, 656.25. So I subtract those. $343.31 millimeters squared. And what that is that is the area of this segment here. So that is the area of this piece here that's been taken out. So to find a volume, remember a volume is an area times a distance. I'm going to find this area here and multiply by the distance of 80 here. So that area is going to be the 200 times 60. Which is 12,000 square millimeters. And then I'm going to subtract that piece that's missing, this piece right here. 343.31. That is 11,656.69 millimeters squared. So that's that area times that distance, remember, was 80 here. This distance right here. So the volume is 11,656.69 times 80 millimeters. Oops, right here. Giving us 932,535.2 millimeters squared. Now, yeah, that's a big number, close to 1 million, so let's convert it down. Oops, that should be millimeters cubed, not millimeters squared. If I want to change that into centimeters cubed, remember on the chart, I've got meters, decimeters, centimeters, millimeters. Going from millimeters to centimeters is one spot to the left. So how many spaces does my decimal point have to move here? 3, because it's cubed. Very good. So I go 3 spots to the left. 1, 2, 3. That's 932 point. We're going to go 54 centimeters cubed. Any questions? Josh over there doesn't comment when you get it right, does he? So this piece here is the arc of a circle. These both come in tangent there and there. I'm going to tell you that this here is 200 millimeters. And we're going to call this one 100 millimeters. We're going to call the diameter of the circle, let's go 200 millimeters. We're going to keep our numbers nice and simple. I want to find angle A, find X, and total area. Where would I start on a figure like this, creating right triangles? Well, we have a right angle right there. We can use that. Maybe cut it like that. We have 2 sides of that one, so we could find a lot. That could be useful. Where are some right angles that we don't have marked already? Where can we create some more right angles? Off of here? That angle might not be right angle. We're not sure. But when we have a circle, where can we find right angles? The tangents. We know that's a right angle. That radius to that tangent is a right angle. That radius to that tangent is a right angle. Again, how much good that'll do us, who knows? Remains to be seen. We do know each of those is 100 millimeters. Now, I did that radius and diameter the way I did for a reason. There's something kind of special that happens in this problem that you don't get this lucky very often. Can anybody tell me what it is? Well, more specifically, what type of figure can we create? It's a 4-sided figure, but we can create, if I do that, because this is 100 and that's 100, right? And because both of these are right angles, this makes a rectangle here. Which makes our life a whole lot easier. If you don't recognize that, this problem becomes extremely hard. Once you see that, once you get that rectangle, this problem actually becomes quite easy. Because now, we know that's 90 degrees. I know that's 100 there, and I know this is 200 here. To find x, it's really simple. How do I find x? A squared plus b squared equals c squared. So x squared plus 100 squared equals 200 squared. So the square root of 200 squared minus 100 squared 173.205 millimeters. So we found X already. Find A. I want that whole angle, but I know that this part of it's 90 degrees, so if I know this part, those two will add up to A. How would I find this angle here? Well, in that triangle, I'm going to go with the sides that I was given rather than the ones that I calculated. So I'm not going to use the 173. I'm going to use the 100 and the 200. The 100 is the opposite side. The 200 is the hypotenuse. So that is sine. So the sine of that angle, the opposite side is 100. The hypotenuse is 200. I am going to do an inverse sine. Which tells me that theta is 30 degrees. So this is 30 degrees, which means A is now 120 degrees. 90 plus 30. What do you think? Area. Well, the area of this is going to be actually quite simple. This angle here has to be how much? 60. This one's 90. So that means this angle over here is 210. 360 minus 90 minus 60. So I have three parts here for the area. Part 1 is this rectangle, which is 100 by 200 millimeters, or 20,000 millimeters squared. Part 2 is that triangle, which was 173.205 times 100 divided by 2. $8660.25. And then finally that sector there, which is going to be found by taking the whole circle, pi times 100 squared, times 210 over 360. So 3.14 times 100 squared times 210 divided by 360. 18, 316, 67. So 46,976.92 millimeters squared is the area. What do you think? Not so bad? Okay. Those two problems are going to be different numbers, of course, are going to be on the worksheet I'm going to give you today. And those two problems will be fair game for the quiz that's coming tomorrow. A problem that was on the last quiz that people struggled with, that I want to go over, and might be fair game for this coming quiz. Look something like this. So let's say we've got a diameter. Oh, let's go 32. Diameter here of 44. across here, we're going to go 20. Across here, we're going to go 44. X is the whole length. I want to find X. And the total area. Now, a lot of people doing this one, for X, we do have this radius here, which is 16. We do have this radius here, which is 22. A lot of people took and they put another 16 here, and another 22 here. Not quite correct. Because the 22 is the radius, we go from the center to here. So from the center to there, that point is going to be less than 22, less than a radius. This is the 22. Now, fortunately, with that triangle, that green line there, if I draw it so that it intersects at a right angle, does cut this in half. So this is going to be 10 and 10. So finding that distance is pretty simple. This distance here is just going to be, if I call that distance A squared plus B squared equals C squared. A squared plus 10 squared equals 22 squared. And I solve for A. I don't know why I wrote that so small. I'll put it down here so I have more room. So A is the square root of 22 squared minus 10 squared. So 19.596 millimeters here. On the other side over here, we got a similar thing. This cuts that in half, so this is 10 and 10. This is the radius, so this is 16 and 16. If I call that B, I've got B squared plus 10 squared equals 16 squared. So B here is the square root of 16 squared minus 10 squared. 12.490. So there's X right there. 16 plus 12.490 plus 44 plus 19.596 plus 22. So 114.086. Millimeters is X. And now for area, we've been over this one a few times before. We have triangles. This one right here is a triangle, and that is going to be 12.490 times 20 divided by 2, otherwise known as 124.9 millimeters squared. This one over here is going to be 19.596 times 20 divided by 2, otherwise known as 195.96 millimeters squared. Piece 3 here in the middle is just 20 by 44, 880 millimeters squared. And then we have the sectors. So it's going to be piece 4 here and 5. To get those, we need some angles. You need to know this angle for this one. Well, I can't find that angle directly, but what I can find here is I can find this angle right here. Once I found that angle, I can double it to get this angle, and then I know that subtracting that from 360 will give me what I'm looking for. So this angle here is found with an opposite and hypotenuse. That's a sine. I'll redraw that triangle. This is 16, this is 10, and here's my angle. So it is the sine of theta equals 10 over 16. So we're doing an inverse sine. So theta equals second sine of 10 divided by 16. 38.68. So it's 38.68 degrees. We're going to double that to get this whole angle here. Then I'm going to subtract that from 360. Gives me 382.64. That's this angle here. Degrees. That's the angle I needed. So now for the area of piece 4 there, it's the area of that circle, pi times radius squared times 16 squared times 382.64 over 360. $854.39. Millimeters squared. And then piece 5 over here, I have to do the same thing. I've got to find these angles. So that's it, 10 and 22. This is 10, this is 22. So this angle here, I'm going to skip some steps, is going to be the inverse sine of 10 over 22. $27.04 degrees. Again, now I need to double that because I want this whole angle. So times 2. And then subtracted from 360 to get this angle here that I need. $305.93 looks like. Degrees. So I did something wrong here, didn't I? I wrote down 382 and that should have been 282, which makes this answer here very, very wrong. Let's go back and fix that. So it's 282. We've got pi times 16 squared times 282.64 divided by 360. 631.10. That sounds better. Now for number 5, we're over in this circle now. It's pi times that radius is 22 squared. That angle is 305.93. And of course over 360. 3.14 times 22 squared times 305.93 divided by 360. 1291.50. Which is going to give us what? $3,123.46 millimeters squared, it looks like, is our area. Any questions? So a problem like that might be fair game for the quiz too.
What about number 2 on the first worksheet you guys?
That's the cone type one?
Yep.
Looks like this. One 4 aspect ratio. Said this width from here, I'm going to change colors. From here to here is Y. We're asked to find that. We're asked to find total height. Well, we can do this. Right angle there. And there. And I know those are 44 and 44 because of the diameter of 88. I know that's 48 across the bottom because I was given that. So what we're going to do from there is we'll cut it across here. We know that's flat. Now we're going to do some fancy cutting. I'm going to cut it here. I'm going to cut it here. So what I have here, this is a rectangle. So we've got right angles here, which makes this right angle there and there. So I know that this section up here is 48 millimeters. I need to know this angle right here, which will be the same as this one, of course. And that comes from this 1 in 4 aspect ratio. I can draw that like this, the 1 here and the 4 here. So that's this angle right here. That angle involves an opposite and an adjacent side, so it's a tangent. So that is going to be the inverse tangent of 1 over 4, which is what, 1404? 1404. So having those angles, what that means to us, this whole angle here is 104.04. This whole angle here is also 104.04. That's 208.08. I've got 90 here and 90 here. That's 180. That's 388.08 degrees. Okay. This is 14 here. I added the 90 to it. I've got, this is a 5-sided figure here. So I'm looking at that bigger one now instead of the rectangle. I had angles. This is 104.04. This is 104.04. So that's where the 208.08 came from. This one's 90 and that one's 90. That's where the 180 came from. A 5-sided figure has to have an angle sum of 540. So I subtract that at 151.92 degrees. That would be this angle here, 151.92. I can split that. This is 44. This angle is going to be half of the 151.92. So it's going to be 70.96 degrees, or 75.96 degrees, sorry. Once I have that angle there, I can find this side. That side would be this here, which is just going to be half of that piece Y. And I can find this side. So I'm going to find the bottom side down here first. I'll call these sides A and B. So I'm going to find A first. A is the opposite side. We have the hypotenuse, so that is a sine. So for the sake of time here, because we're running a little short, sine of 75.96 equals A over 44. Put this over 1 and cross multiply and divide. A is 42.69. I know I'm going a little fast. So you got 42.69 there. Now what that tells you, by the way, that's 42.69 times 2. Like I said, that's Y, 85.37 all the way across here. The other thing that tells you is I can take the 48 out of here and put half on each side so I can get this side here. So if I'm looking at that little triangle right here, so I can find this height to get X. So that's going to tell me what do I have there. This ends up being 18.69 millimeters, I believe. Because you got the 85. Well, I took the 42.69 and I subtracted 24, which was half of the 48. I was just working from the center out. And then this is still your 14.04 degrees here, so you can find this dimension. So you have that dimension there. That's this piece here. You can find side B, which is going to be this piece here. It's going to go from here to here. Then you got a radius that'll take you to the top. That'll help you find X. The tough part, like I said, is not doing the calculations. Once I get the triangles here, you guys can find the missing sides. The tough part is finding the triangles. And you can see sometimes you've got to cut up a shape to find triangles to find missing sides, and then erase those triangles and use those sides to create new triangles using those sides and work from there. So I mean, it's not easy. It's just a matter of repetition and learning to see the right triangles within the larger shape. Okay, I've got a worksheet I'm going to hand out to you to work on here for the last 10 minutes.